Hi, hello, I am Kiran Kumar from Nature of Physics. Today topic is block sliding on a rough horizontal surface. Please do like and subscribe my channel student and watch the full video, you will get clarity on the concept. See student, here a block of mass m taken and upward direction normal reaction that is perpendicular to the surface. Next mg is weight acting downward direction student. Okay, a person is kicking the box student, so that the box have the initial velocity is u and final velocity is equal to 0 student, and time taken is t, and change in velocity give the acceleration, and this is the initial position, this is the final position student, and there is a displacement between the initial position and final position is s, so that there is a frictional force is kinetic friction because of it is in motion. So that I am going to find the first acceleration, second displacement, third time taken student. So that first acceleration, the basic equation I am going to write resultant force m mass moving with an acceleration a, ma is the resultant force. Towards the resultant force nothing is there student, any force is there? No, just person kick. So that force is equal 0, and opposite direction what is there student? There is a kinetic friction, there is a kinetic friction student, and the basic formula for the kinetic friction Fk is equal to mu k into n student. Okay, so that ma which is equal to minus mu k into n student. In this equation there is a apparent weight of the person which is balanced by the normal reaction, both are equal in magnitude and opposite in direction student. So that I can write there n is equal to mg student in the above equation, so that ma which is equal to mu k into mg, here I forgot to write the minus sign, so m is get cancelled student. Next step I can get here acceleration a is equal to minus mu k into g student, this is equation number 1. So acceleration of the block a is equal to minus mu k into g. Try to understand student, here force applied only, so continuous force is not acting, that's why along the direction there is no force, applied force. Next displacement I am finding student. For displacement the best equation is v square minus u square is equal to 2as student. According to the diagram clear information, final velocity is equal 0 square minus initial velocity u, so that u square is equal 2 into a value how much we got student, acceleration from equation 1 mu k into g replacing here, and displacement is writing s student. So that next step minus u square is equal minus 2 mu k g into s student, minus get cancelled there. So displacement I am writing there u square divided by 2 mu k g is equal to s student, this give the displacement is equation number 2. Okay, and next one third we are going to find the time taken student. For time taken, initial position to final position is t student. The best equation v is equal to u plus at, so that final velocity is equal 0, initial velocity is equal to u, and a value is here first equation minus mu k into g, time is t. Okay student, now rearranging this equation, that is mu k g into t which is equal to u minus become plus student, so that time taken t is equal u divided by mu k into g student, this is equation number 3. This is the clear information about the block sliding on the rough horizontal surface. Please do like and subscribe my channel. Thank you student.